Hello friends, welcome to Data Pandit. So today we are going to talk about max score in rollup, but in the sense of how in memory, rollup processing happens. In memory rollup process, right? So what is there in that is like whenever we configure, we don't have sorted data and we have unsorted data, right? And we want to utilize the rollup component. So for grouping purpose, okay, and we don't want to sort it explicitly, rather we want to make sure that rollup itself does the sorting and then try to group and all, right? So therefore, we have an max score parameter, for this rollup component, right? So that this is a kind of primary memory allocated for rollup component for this purpose only, right? So it can have a in-memory grouping and based on the size and all. And if it is goes beyond, then it is trying to spill the data into the disk and then it try to manipulate that based on that. Okay, but at certain limit, it will try to do in everything in memory. So we are going to see how the algorithm works and in what cases in memory is sufficient and in what cases the spillage happens and how much it and what are the a factor are going to decide the spillage, right? And all those things. So let's check this graph. Let's say for example, we have this graph, right? We have an input data and then we have a roll-up component and output. So this is there is a max score, let's say, okay, in memory sorting happens, in memory kind of roll-up happens, okay. So we know that if data is sorted, the rollup is, does the grouping and the produce the output. Nothing max score is required in that case. But if data is not sorted, not grouped, right? So in that case, rollup also needs to take care of the grouping and everything, the involved sorting probably and all. Okay, because it has to produce the aggregated data, right? So what happens is, let's say whenever rollup tries to read the input data and it will create the hash table, okay, in memory hash table. So something like this, let's say this is the table, right? So we know that we will have the key, right? uh, Key for the rollup, right? So let's say we have key column, right? So for the rollup we know that based on that we have to give the aggregated data, right? So let's say we have some key. So it will try to read the data and it will produce the hash table. So this is the hash table. This is called hash table. So what are the columns in hash table is like key and value, key of the rollup and the value for that. And then there are field. What are the pass through fields are, okay? In the sense of, let sometimes we have the aggregated data also, but some pass through fields, right? Let's maybe customer ID or those kind, although department ID or those kind. If we have a customer data and want to see the total purchases, right? So what we will have is we will have some kind of date. It could be, right, and it could have some kind of pass-through fields. Whatever is there in the input, what the same is mapped to the output is called pass-through field. So these field one and field two are, let's say, pass-through fields. So this kind of hash table is getting created. Okay. So in hash table there will be a key and aggregated value, and okay, based on the roll of function, right? Whatever we are using, maybe count, sum, max, minimum, right? So all those based on that and pass through fields. Okay. So this is the hash table size. So the number of columns in the hash table will depend upon the how many pass through fields are there and what is the key and value, and the rows in the hash table is going to be decided by how many different distinct key values we have, right? So those many records is going to be created in hash table. For example, we have an input such that, so let's say we have max score is assigned like max score, how much max score will be 64 MB, let's say max score value, okay. For example, that is 64 MB for the roll up. So as long as we have a data in hash table, you know, the total number of size of this hash table is well within 64 MB. So up till then, there is no spillage happens. So this is the question of spillage. When to spill? It says that this question we are going to answer is like when to spillage is as long as so the size of this hash table, right, is less than the size of the max score. Until then, there is no spillage happens. Meaning, input size must be, if we are configure max score as 64 MB, input side should be not input side basically, but the size of this hash table, the key value grouping, and also the pass-through fields. Okay. So it is directly proportional to the distinct key values actually. So the max score value uh, is directly proportional to the hash table's key value pair basically, right? And the number of fields and all. And there is an you know so because this hash table and then indexing is also there, so that kind of extra memory is also required. But ideal case, like if that altogether this size is less than that of the max core memory, right? It doesn't depend upon the input file or size of the input data, but it does depend upon this one. Okay. And how much it can be spilled, right? So in the case of, if the hash table sizes is less than max core value, nothing will spill. But in the case where let's say this is filled up and we have more data to read, let's say in this case we have 100 MB data to read, right? 100 MB input size. Okay. And 100 MB input size, and then so we try to fill it up. Okay. And and it comes out that maybe it could be 100 MB or maybe beyond that, because this hash table size doesn't depend upon exactly the input size. But let's say this hash table is filled up, okay, and we have some more key value to be stored, to be read basically, and this key value is not there, so that's this values cannot be identified. So, okay, so we have got the key k1 and we have uh, put the entry into the hash table, then k2, k3, k4, then again k1 came, then because it's a repetitive, we have modified this aggregated value and it keeps on happening. And at the time when size is goes beyond this max score, then what happens is we have, let's say, key 100th key is going to be read, and this is filled up, k99 is like filled up. And what happens is k100, so this k100 data will go into the disk. Okay. And all the data after the k100 k01, k101, k102, all those things will be spilling to the disk. Okay. And okay, while spilling to the disk, it will take care of, I mean, which key value is spilling to where, right? So those kind of intelligence is happening while processing, right? So in this case, so after that, let's say we have read everything. We have K200 values. K99 is already stored into the hash table, and all the things has been read. Okay, okay, and all those things from KG1012 to K200 is on the disk. Okay, then it starts doing the output. From hash table is getting emptied one by one. So all the key groups are getting processed because it's an in memory. So that is going to be kind of emptied. Okay, and then what happens is all the rest of the things will come into the hash table and then go to the output. This happens. Okay. So let's say, okay, let's say uh, K99 is already there, right? From K1 to K99 is getting output, and rest of things, right, from K9 K100 to K200, all those things will be pulled into the hash table back again, right? Okay. and in this way then it will be output and all, and this way it happens. Sometimes what happens is, okay, because we have data from k100 to k200, right? So this is the kind of, let's say, small data, but there are lots of data. Okay, so then second iteration of spillage happens actually. So what happens is, first iteration happened, then the temporary file is come into the hash table. Let's say in this time also all the temporary file is, all the records which key groups, right? All the key groups are not able to reside into the second iteration or second time also. Then what happens is, the rest of the thing is going to be again spillage happens. So there could be a multiple iteration of the spillage. Okay, if the keys groups are very huge. So this is when the second iteration of spillage happens. Okay. Okay. Therefore, what we need to do is, we have to take care of the size of this one. We need to design the graph, and we need to run the graph with the production like data, right? Real data, and then try to calculate the good size of the max score, and then configure the rollup and then try to use it. Okay. Otherwise the double spillage happens. So spillage is like input output happens. So we need to avoid the input output so that our graph performance improves, right? So that's when the max score is very important over here, and it's depends on this hash table, and the number of distinct key values, and the amount of spillage is depending upon the your max score configuration related to the size of this hash table. Okay, so this way we can configure our rollup, and we can make our processing optimized. Thank you so much.